You have seen the fab stove working already, and we are not allowed to have any fires, so I cannot light it. Okay, the barrel is over there, and we can talk about it and the intricacies and how to build it, and there's instructions on the internet, and I want to direct you to those so that you have these resources for afterwards. Okay, the T-lead barrel, flame cap kiln, rock kiln, a recognition, a break somewhere about 10, 9, 10, whatever it is. CHAB is the computer software program on tracking it, and there will be a live demo today. First time done. Daniel has put data in Venezuela. Now we've made it up as a demo, but it can be, we'll be faking the data, but you get to pretend that you are collecting char, and it's going to send it off, and you'll see some of the steps that go with it. It's the beginning stages. It'll give you an indication of what it is. It is certainly not the full package, but what can be possible. Biochar characteristics. The BBM method is by Hugh McLaughlin, and he's a specialist on characterization of chars. He lives in Massachusetts. He has an excellent 45-minute recorded presentation that he gave to the Green Carbon webinar series. And my proposal is in the afternoon, we will, those that want to, we will watch the video, the 45 minutes, and you're getting into the nitty-gritty about what temperature should you dry your fuel at? What's the impact of doing your ashing at one temperature versus another? And what is the difference between the IBI method, we'll call it the American method, but the IBI method, and the European, the EBC method, and the BBM method, which is showing up some of the characteristics of how these interrelate. A very interesting topic. Cannot be done this morning. It is definitely into the afternoon or into the evening or into tomorrow for that matter. So on that topic of that, how many of you would come by and watch that? We're going to have 3, 4, 5. Good. I got enough people that'll come and see that type of thing. Okay, but you don't want to see that now. That's not why we're here. We're trying to get through some of the key elements that go along with it. I am okay. I am Paul Anderson. I am a retired university professor of geography. I am 79 years old, older than 2 of you put together in some cases, and this type of thing, all right? And that means a different stage of life and a different objectives from what other people are doing. If you have any doubts about it, I am on a recruiting mission, and you are the targets, okay? And into what can be happening, what can be done. You can make any proposal to me that you would like, that you'd want to see the fab stoves, or you'd like to see the rock kiln technology, or the BBM stuff, or all these things. Let me know. You people are the conduits back to your individual countries and places, etc. I have been to many of your places. I know people probably in most of your countries, link you up with them. What can we do? And try to do it together. My license plate on my car, my license plate says juntos, or juntos. That in Spanish and Portuguese means together, okay? Like a military junta, okay? That means these people together are ruling, okay? So it's a Spanish word. That has been my key word on it, to work together. I need the other people that are in there with it. Daniel is having a project in Venezuela, and it is Juntos Biochar, okay? And what he is looking at in there. He also has a non-for-profit on there, okay? In Kenya, we have a project which is Biochar Pamoja. Pamoja means together, okay? I don't have to live with that. It doesn't got to be that way, but something in Norwegian would probably come out just fine. Who knows? But sometimes it doesn't work. But working together, doing these types of things, okay? I need to give a little bit more of the background of how I got started in this thing. I mean, I've lived 20 adult years outside of the United States. I appreciate third world, developing countries, societies, and stuff like that. 2 years in Mozambique, Africa, 5 years in Brazil, where I was a professor at the University of Brasilia. I'm fluent in Portuguese. That's why I can handle those two countries, okay? And my PhD is from Australia, so around a few places. In 2001, and I was 57 years old, so therefore you're all younger for starting on this than I was when I was introduced to the concept of pyrolysis. Hey, I knew it from Boy Scouts and chemistry class, but what it is as a process. A friend of mine, by the way, I'm in Rotary Club, okay? If you know the Rotary Clubs, we'll link in with them. We'll try to do them as much as we can in that regard. I've been in Rotary for more than 40 years. So I'm setting up a Rotary Club, and a guy who lives 4 houses away from me, I'd never met him in 20 years in town, and he ends up joining this Rotary Club that I'm forming in there. His name. And he says to me, Paul, come and meet my cousin Tom. He's as weird as you are. You can't pass up that type of an invitation, okay? I mean, I don't claim to be totally normal, although I live in the town of Normal, Illinois, okay? But I went to meet them. I saw a prototype, an earlier version of the fab stove on a kitchen table and inside of a house, had a fan in it, with the fan in it, had used pellet fuel. We lit it up and we made rooibos tea on it to celebrate international type of stuff. Tom Reed, and he's an international expert on gasification. That same afternoon, I said, I want that for all these countries that I deal with. I want that for the rest of the world. I didn't want it with a fan in it. This is 2001, okay? Now we're 22 years later, and fans are a lot easier and stuff like that. But just said, we're going to have, I didn't want the fan. Tom Reed forgot to tell me that he had already determined that you couldn't do it without a fan with the pellets. So 4 years later, 2005, I had done it. And then 2 years after that, I found out that a Norwegian, Paul Wemblebo, okay, had done it in Uganda 12 years before I did it, in the 1990s. Tom Reed was doing his early stuff in the late 1980s. Wemblebo and Reed are the two fathers, the principles, the concepts. There's a document at my website that talks about the origins and history of TLUD gasification, these types of things. I've got the flip chart here, and among the things which we're going to be putting down is some key websites, okay? And the main website, they're all got the www, right? Woodgas.com. Almost everything I'm talking about and showing today has something at woodgas.com that relates to this. And the slides that you've got and stuff like that. The other one is, I'll do it in lowercase, drtlud.com. drtlud.com. But I'm transferring my content from drtlud.com to woodgas.com. That's the main one is there. There is a section of the key items that have come from the drtlud.com, but not everything is transferred over. There might be a few things we're looking at. For example, McLaughlin's conference paper on the BBM is in there. And it's a link that can follow through. It's on one of the two sites. It's easy enough to find the different documents that I'm going to be referring to. All right. So I worked on trying to solve this problem of gasification without a fan, and the result was the Champion stove. You saw one of those. We didn't light it up, and I have...
It's there. It's over there.
Oh, okay, yeah, and here, then the other parts are over there, I think. Okay, yeah. These are the legs. This is from India. And the other parts of it are over there. Can you find it? We'll get the concentrator lid and the top. There, it's in the plastic bag right there. I think over to the right. There you. No, next one over. Is there? Okay.
Yeah.
All right. So these can be taken apart and transported, and you can get them someplace. Champion stoves are not for sale anywhere. In India, they are part of a project, and they cost $40 to make the Champion stove, and it's going to look something like this. Okay, this is the top. It's got 3 legs coming down from it. That's the stand. We had one over there, but we didn't light it up. And then that stand sits over the top of it here, and you put the pot up there on it and everything. Okay, so I worked on this. The key, concentrator lid, concentrator ring, whatever you want to call it. The concentrator brings the combustible gases together, forces the mixing with the air, the secondary air that is coming up between the 2 walls there. It comes in through the side. Some of the air comes in underneath the grate that's down in the bottom. Okay? 2005, I made the first stove of this style, not knowing anything about Wendelbo, okay? Actually, I was in Bolivia. I took it back to the States and went to Stove Camp, which is I was out in Oregon. How many of you have heard of Aprovecho and the Stove Camp? A few. Lots of good stuff there. I've been to 14 stove camps. I mean, some of them I was leader of it, some of them I was attendee. But I always worked on gasifier stoves, okay? And other people are doing rocket stoves and things like that. We're going to talk about the advantages of these stoves in just a minute. Obviously, what coffee is served, and let's, in the spirit of being flexible, maybe you want to put that over on that table there, and people can just get up and go over and pick it up. And that way, we are going to talk about lunch at a time here and how we're going to get this handled with everything, but not quite yet. But right now it's coffee and looks like maybe some donuts even. And thank you to who provided?
That was Sanjay.
Sanjay, hey, all right. Okay. So feel free to get up and move around, and it won't bother me at all. If you fall asleep on it, I was a professor for 30 years, okay? The largest class I ever had was a little over 300 students. Most of them were like 80 or 60 students and stuff like that. I talked with smaller groups. I try to present, okay? And I hope I got some content for you. Yes?
Do you want a timekeeper?
Yes.
Yeah, how long do you want per session?
Let me know, what time is it right now?
It is 9:13.
9:13. Okay. Yes, you can keep.
30 minutes, 20 minutes per session?
No, they won't be gauged like that. You just keep me on track. At 9:30, I mean, I get 15-minute intervals. Say, hey, 9:30, and I'll just wake up call, Okay. So so if you want to deal with natural draft TILA stoves, one of the things we'll do is we'll put it together, okay? And I'd say maybe if we slip off into the woods someplace off campus, and or another thing is we go to the fire department and ask the firemen to come out and supervise that we never mind, okay? trying to solve these things without getting kicked out or anything. So,
The price here is $40. What did you say?
okay, $40 included that tripod, 2 of these canisters, 1 of those, and that's in a project that's then in India. Indian prices for production. This is in West Bengal. They are in a project, so there is no markup for retail and for the salesman and the distribution channel and stuff like that. This is in a project which now has over, last I heard was 150,000 of these stoves in use, and I know more about the first 100,000 of them. And they are getting carbon credits. That's part of our financial stuff. You want to talk about carbon credits? We can get into that and into the details. Yes.
And for the case in India, what are they using the same fuel or are they using their own?
They're using what I call split wood. They buy. This is in the delta of the Ganges River, extremely densely populated rural area. The timber is coming from the sustainable forests 2 hours to the north, and it's an industry. Okay, that they bring it in. What? No, sticks, wood sticks. I call them segments. That'll fit. Okay, so wood sticks, and so
It's available for everyone.
yeah, it is. But you do have to get it organized because the lady of the house is too busy to be responsible for an additional type of fuel handling, unless you made it. I mean, unless she's out there, she's walking 2 hours to get wood and then walking back, and before she can cook, she's happy with anything that'll help on that. But these are some of the realities that we have. They send the kids off to. I've been going to stove conferences, and these topics about the hard labor, the inconvenience for the women, the smokiness, it costs too much, all the different reasons for it. I can go on this topic a long, long time. Okay, so and that's on the natural draft one. I'm going to go quickly through the part on the fan one so that I can move on to the next topics in there. So all right, how many of you have an interest in cooking stoves? Oh, there's a few there. It is going to go into the afternoon. I mean, if I spend all my time on it now, we don't get to the other topics. But that's a good indication that yes, we will come and we'll do it. Okay, I designed the stove, the principles of it. A separate company in India did the making it stainless steel, getting the parts together, things like that. I am not a manufacturer. I am associated with these things. I sometimes get a little bit of benefits from things, sometimes I don't, but I'm not the owner on that type of stuff. So that is the fab stove, or not the Champion. Oh, at the stove camp, they have equipment to measure emissions, carbon monoxide and smoke, the particulate matter. Okay, I was at stove camp in 2004, and they are building the equipment. $40,000 worth of equipment was in, but wasn't up and running then. 2005, I'm back at stove camp again. That's my second time. It's the first time with the Champion, with this stove that I brought from Bolivia. Swept the field, cleanest stove. I won the prize. That's why I called it Champion. The way that they used to test cleanliness of combustion back in the time of Sir Isaac Newton and Bacon and these other early scientists was they would take some cloth and dip it in cat urine. Very pungent, smelly, bad stuff, okay? And when the stove is operating, they would throw that into it, and if you could not detect the odor of it, then it was a clean stove. If you smelled the burning cat pee, it didn't pass. It wasn't as good as it could have been. So it was called the Cat Pee Award. So I won the first Cat Pee Award when it was done, and I claimed the name Champion Stove off of that. Yes?
Sorry that I ask you, but it's coming to mind. If you put this for the cats, for the pets, but the pets will get dark, and people might do not be comfortable because we use wood pellets,
Yeah.
and it's very popular. I'm thinking this could be excellent, but how do you deal because the white cat will get all dirty? It's a good idea, but I don't know how.
I'm not so sure about that one. I'm not.
It's good for a bed of the cats.
Yeah. That's kitty litter. That's something else.
Do you need that I bring?
I want to get one out, please.
Can't do it.
I got the other one put away. All right. I'm now going to talk about the fab stove. You've seen it operating, the fan and it blows and stuff like that. Cleaner combustion. I have 8 of these fab stoves shipped from California to here. They're made in South Africa, brought to the United States. They are up on the internet and for sale at $199, okay? Basically a $200 price. We'll set it up on top here.
You?
Then we'll open it up, please. The story is that my designs with regard to the and I've got those things on the table there. We can pass the sheets around to everybody. Okay. With my designs, a man named Dave Lello in South Africa did development work on to make it a better design. There are other ones which have fans in them. This is the best one. I can talk about Mimi Motor. I can talk about that's something else for the extra discussion time. And what's in there? Just that's to keep
power. Nope.
No, there's no power thing on it. Where's the? Oh no, it's just got a cable. It runs off of a USB thing here. Please note that underneath here you see a serial number. Okay, each one is done in there. So what I did, I financed Michael Whitman, and pass out those cards and the sheets of paper, please. Michael Whitman to import to America 300 of the fab stoves, okay? They're half gone already, okay? He's selling them. And they're the only ones available on the market. Dave is trying to make another one that will go with projects and stuff like that. This is we call it model 1.5. All right. This says one canister comes in. We can look at it and it slides. There's a riser here and it comes out. This is what you get, okay? And it runs off of a USB port, 5 volts, just like your thing. Why did I have 8 of these things sent here? Because taking these legs apart, you can put it in your suitcase and take it back to your country, and it would cost you something like $250 to $350 to do a shipment, a separate freight shipment. You put it in your suitcase, your transportation is free. I can't give you the stove, but I made it possible for you to take it if you want to, and that's something we'll talk about later on. So they're brand new. They're over there. I've got 8 of them. There we go. Yeah. And that's this afternoon. We can go over it more, the usage of it, these types of things. Without obligation, how many of you would consider wanting to have one of these to take with you? 1, 2, 3. There's 5. Some of them are going with Daniel for his project, which I'm helping sponsor in Venezuela. I have no problem if people don't get any of them. They don't have to have any of the stoves. But at the same time, he's staying a few extra days. I could have another box of 4 or another box of 8 shipped to here, but it will only arrive probably as it's ending. But he's sticking around a little bit later. Okay.
Available in South Africa before they get exported?
Nope, he doesn't have any more. I'm going to show you what is in South Africa. Yes, I thought you'd never ask. That's the question. Okay. This is This is model 2.0 of the FAB stove. And I'll set it over here. And I don't want it to scratch the stuff like that. It is, this one, it comes out like here. It doesn't have that, okay. Has a controller on it. The battery is dead on it, but there's a plug that comes in to there with that. And it runs just like the other one into there. This one here, stainless steel on the top, is going to become available. If you want to do a project in Ghana or wherever you're at, you don't want to have them build them in South Africa. You want to get the legs coming in a package like this, your top and bottom in a package like this, and the cylinders come like this, except this is just for one unit. You want to buy 500. You want a project 2,000 units. You can come in, you can get it totally flat. You do the rolling in the country, everything else. If you want to have, just a second, I gotta catch my breath. Okay. If you want to have the industry in your country, and you have the capability for doing the laser cutting, an agreement can be done with the Fab Stove Company for that to be done also. Everything is possible on here, okay? So the just a fair royalty thing that goes to Dave Lello, and that's in good. This afternoon or tomorrow, this is one of our extra topics. We're going to open it up. We're going to partially assemble it. It's going to end up looking something like that, but we have to disassemble it because it's got to go in Daniel's suitcase to go to Venezuela. Okay. Okay. So so that's the story on it. This one here is that's just another one of those. A little tidbit. This one has a mesh on the outside. There are variations that could be done. You could design it so that in Nigeria it's different, or then in Thailand it's different. You can get your pick of what you want, okay? One of the things which I think is on this level right in here, which does not get hot, it should be painted, it can be powder coated, stuff like that, but you could put advertising on there. A company which sells cooking oil, I think, would like to have its name in everybody's kitchen right there when they're cooking, or baking flour, or that type of thing. So those are all extras not even implemented yet. We're the wild, wild west. We're at the cutting edge of so many different things, and that's why I'll take that question, and then we'll move on to the other.
Or even the company that is going to provide us the PKS, for example.
Yes, yes, or the project owner. It says Fundación Senderos. That's his project. It could be something else. It could be a World Food Program. Question.
In some countries, there is no wood pellets.
Yeah.
Like in poor countries.
Yes. Okay.
So what should, like, for example, I want to take it to the village where there is no pellets. They have a lot of woods, but not pellets.
Okay. Some of the principles that go along with this. The density of the fuel will impact how much energy comes out. The diameter influences how much heat's going to be coming at one time, the intensity. The height of it very strongly influences how long it will burn. You can use these stoves with just wood chips and small pieces and stuff, but it's going to end in 15, 20 minutes, maybe half an hour. But we have success with PKS, palm kernel shell, which is all over the place. I mean, African oil palm, and this is it's a leftover from the industry. We burned it yesterday. We made some. That's another thing for the afternoon, things that we'll talk about. Yes, my timing?
That's actually not what I was.
Okay.
It is 9:30.
That too.
Okay.
But, I don't know much about like creating pellets. Like, what is the feasibility of having like a small scale pelletizer to where like a village could make their own pellets out of woody biomass?
Oh, okay. We're into some of these questions that will go into the afternoon, but the quick answer is this. Pellets are sometimes made for cattle feed and things like that. They don't stick together well. It's not the same as the wood pellets. Wood pellets, the best stuff of it, it's harder material. You have to have the electrical power to run your pelletizer. You need a bunch of things like that. Dave Lello works on those also for mobile units. It can be made and then shipped in a container and put on a pellet factory. Think of it as $80,000 to $100,000, and it can put you into business. And he wants to do it. He's looking at doing it with elephant grass. Yes.
So, if for example somebody is using this, he will when he uses it, he can also get the biochar, or it will be ashes.
Oh,
in the home.
In the home, okay, this is part of the explanation. When the fire is finished at the top, because it's burning the gases, when that fire disappears, air continues to come up and is now burning the char. That's the time that you remove it. You dump it out into a container, put a lid on it. We like to weigh it when it's dry, but if you that's part of the getting carbon credits things for it. But if you're not happy with it, if you're happy with just putting water on it, that's fine also.
Okay. And if, for example, the sawdust can be used.
No, sawdust is too fine. It obstructs the thing. Rice hulls are also problematic. I'm not going to have it.
For example, I deployed it in like maybe thousands of homes,
Yeah.
and I trained the homeowner that
Yeah.
you should give me biochar, bake. I
Yeah.
give him like wood pellets, and can I like use the claim the carbon credit?
Yes, if you're the owner of the project and these people agree that you are the one that has the rights to claim the carbon credits, they sign a contract on it, because an individual homeowner cannot possibly acquire that, okay? They can't claim it and stuff. But that is down into some of these others, the financial stuff. We're going to get to those. It is these questions, and I'm going to be here. As long as somebody's got a question, I'll be happy to answer it. So and we don't necessarily get to them all. But I'm pushing forward on this. I already mentioned those pieces of the cat. That's in the afternoon. That's on the. That's on fab stove assembly, topic for this afternoon. Char track details in the afternoon. This is that. The project planning, I put this here. You want to plan a project for your country, whatever, okay? We're going to start doing those. And if you're from where?
Spain.
Spain. But you're working in Kenya.
Different places. Yeah.
Different places, okay. But we have a project, and where are you from?
I'm from Saudi Arabia.
Saudi Arabia, yes, okay. Pardon me, I can't.
Originally, I'm from Pakistan, but the company I am presenting is from Saudi Arabia.
Okay.
So I'm presenting two countries, Pakistan.
Okay. Pakistan is a great place for it also, the prospects. If you want to talk about the details of Pakistan and Saudi Arabia, we're going to talk, and anybody can listen in, because they're going to say, oh, but why would we do it if we're doing it in Cambodia, or how would we do it there? That's the type of stuff that comes into here, okay? The BBM video, the climate biochar. At my website, I have a white paper, 52 pages long, Climate Intervention with Biochar is the name of it. And it's got 25 sections in it, and section 12 is all about the stoves, and other things are larger and stuff. All of that, I can go through it, and you can be looking at it on the internet, and we can answer stuff. Yes?
There is even in India, the Harvard Business School has a case study in India where the women are affected by the smoke when they cook in the morning.
Yeah.
Especially women who are pregnant.
Yeah.
I think this stove will be very effective in that.
Very effective. Now I'm going to show you something here, and I am more or less on target here. I came to town. You can watch the screen up there. I came to the area here on Wednesday at noon. I spoke at a Rotary Club in Victor, which is a neighboring town here, okay? So I put together a little slideshow for them. I can't give you the whole thing because it's going at the concentrated morning session, but we can go back through this one and 15 other PowerPoints that I've got on all kinds of different topics to the extent that you'd want it. This one here, combined heat and biochar, we use the designation CHAB. Human often I use CHAB. The role of biochar in it. Now, oops. It's about me. I'm not dealing with that. The crisis of climate. We can come back and talk about climate adaptation, decarbonization. Great topic. Maybe this evening, or you want to debate climate stuff. Fine. Not now. I can't do that. Clarification terms, biochar. You guys understand that. This shows the permanence issue and how biochar crosses the bridge to make photosynthesis become long-term storage. Photosynthesis is sequestering, gathering the carbon in. Okay, that's capture, but it doesn't have good storage. The biochar gives it the storage part. Okay, very important aspect of it. Again, many things to discuss with that. This is about cooking and heating. Any of these topics I can deal with, and space heating, how to heat homes in cold climates and stuff like that. This is the champion stove on the right, the Fab stove there. By the way, Fab is fabulous, but it's forced air base stove. All right, okay, so we had to work on that one. Okay, and this is good for a video. Let me get to the right spot here. There it is. This video is showing, lighted at the top, the pyrolytic front is descending down through there, the red zone. Gas is coming up through that black char that's being created, and then it's burned up at the top when the secondary air can come in and give it. And that's what you're able to see for all of that. And then it ends. And when it ends, the upper flame goes out. That's the time you save your char. We don't want to keep blowing air, putting air onto the char, because air onto charcoal is a forge. That's how you make steel soft so that you can work it. You don't want to do that to your stove, even if it's stainless steel. You try not to do that. A little bit doesn't hurt, but the other industries, there are people who say, oh, we solve that because we use cast iron cup in it. We use ceramic things in it. And they're heavy, and you can't dump it out, and you can't, there's pros and cons. I am endorsing the Fab stove. I mean, this Dave Lello did the job that I wanted to have done, and I don't have those skills. He does for the computer drawings, getting the stuff going, talking with the laser cutting companies and assembling them and putting that stuff together. Okay, now.
Can you repeat what you said about what's forging, or like what makes the metal soft?
A forge, yes, it's like a blacksmith. You pump air onto coal, and it will make it so that the metal glows red hot, and it's soft. It gets softer, malleable. Is that clear? Is that more?
Yeah, and so you're saying
Coal burns at a higher temperature than the heat soak.
Yes, coal. When in the steel industry, they do not make steel with coal. They turn that coal into coke, C-O-K-E, and that's heated up and stuff because then it's more pure. This is more like the fixed carbon that we're after with biochar. And then they put the heat on these blast furnaces. They're blowing the air on. That's what makes it so hot that you can make that metal liquid, steel liquid. And you don't want to do that in your cook stove, okay? This is a chart which shows some of the characteristics for emissions. This blue line here, you can barely see it, is carbon monoxide, which will kill you if there's much of it. In a charcoal stove, it's way up higher into here. Other stoves, it spikes every time they change it. This is a result that comes off of like a fab stove, a T-lead stove in there. That is actually from a fab stove. The red line here is the heating level. When you light this stove, it stays pretty constant all the way through until the last 10, 15 seconds. It's a drop off and it's over with. It's very clear to see when it ends. The other measurement, which would be particulate matter, it is not shown here, but it is also extremely low. Particulate matter is what becomes smoke, and that the health problems. Yes.
Could you talk a bit about the instrumentation to measure the PMs?
This afternoon. Okay. I mean, there are. This is a whole thing. Institutes and places that are dealing with it. Great topic.
Yeah, if you had to send it outside of the institutes, like if some of us wanted to do the measurements in our.
You're not doing that. They're not doing that in your home. I mean,
in the home,
but in your place. There are things on instrumentations and stuff, which I brought some stuff in here on scales and the BBM methods. There's a great topic in there. So, just looking at this part and.
The monoxide goes up is after 55 minutes.
Yeah, after the flame has gone off from the top, now we are blowing air onto the hot charcoal, like a charcoal stove, and that gives you carbon monoxide.
Yeah.
So it shows exactly what is normally happening.
Alert for the developers.
Yes, very important. You don't want that to be continuing on, all right? And there you can see a little picture up in the upper right hand, towards the upper right. That's what we saw that yesterday. You were watching that flame. It goes like that for 50 minutes. So this is a nice thing. You can actually walk away from it. You don't have to be there sticking your wood in and stuff. Okay. This is the documentation about cleanliness of burning. This again, it's all at the website and stuff. The ESMAP, which is a World Bank entity, did the testing, did the classification. 2015 came out with these results. I took their things and helped make it clear. The references are given into here as to what I looked at to make it more clear. But these over here are all of the old type of stoves. Charcoal stoves, rocket stoves, wood-burning stoves, three-stone fire, all that kind of stuff. And it just isn't good enough, in my opinion, and we should be, get this out of here, we should be going with the T-lead stoves. On the modern advanced cooking things, we got stuff over here. Solar, electric, and fossil fuels. They're clean, okay, they're good. This is modern. But they're not based off of wood or the biomass that's growing. If you take biomass, you can do 3 ways with it. You can turn it into alcohol. Alcohol burning is a very nice, clean fuel, considered to be modern, etc. Then you have all the deals with that. You can turn it into biogas, those big digesters, and you can cook with that. The only use of solid biomass, which is clean burning and meets their criteria, is this one here, wood gas from biomass. And of those stoves, it is the T-lead design. There is a design called an Anila. Never caught on. It's not nearly as good. Doesn't have the development and stuff behind it anymore. But these are pyrolytic stoves, and only pyrolytic stoves can make carbon negative energy. You cannot get carbon negative, that means carbon dioxide permanently removed from the atmosphere, by any of these. Not with electric, not solar, not fossil, none of those. But because we make biochar, we are a carbon negative cook stove. In my white paper, in my white paper, section 12, I talk about this. The numbers of stoves in the world, we need at least 250 million stoves. We would like to have all 500 million of those. You multiply that by 6 people in the household, it is 40% of the world population. Is still cooking on dung or wood or coal or that type of stuff. That's the size of the market. Yes, Albert?
How much biochar would 250 million stoves produce in a year?
Okay. It's actually in the white paper. I won't go through. It is mass. Oh, yeah, the quick number. Converted into tons of CO2 equivalent, it can go up to half of a gigaton every year if all 500,000 were doing that. Now, you live in households where you are cooking with natural gas or propane. Raise your hand. Or electricity. I mean, okay, these types of things, all right? When the push gets hard here, and electricity price is so high because you got to have it for your car and you got to have it for everything else. When you're supposed to be net zero emissions, so you can't have natural gas, okay? You can't have propane, shouldn't be doing it, okay? And you need the temperatures that will cook. Consider pyrolytic heat. Well, what happens with that? Biochar. That's the key word for this conference, okay? It happens that biochar is a fringe benefit of the cleanest cooking energy and heating energy that's going to be around. The year 2050, supposed to be net zero emissions, okay? It's going to be problematic, folks, and I think that this has an option. Yes?
So how many times do we need to use the cook stove for the cook stove itself to become carbon negative based on like the manufacturing process?
If you're probably using it for 6 months, you're probably more than past it. Yeah, and the stoves, the Champion stove, that one there, the lifespan is about 7 years in India. The project there is now in its 9th year, and some of these stoves have been refurbished. The handle's the same, the outside's the same. They changed the inner guts on it, stuff like that, for a fraction of the cost. So it's now into the second 7-year period, and under Kyoto Agreement, you could have 4 7-year periods of your project for a total of 28 years. I mean, it's out there, able to be doing it. Just don't have any funding.
What's the lifespan of the fab stove?
What?
The lifespan of the fab stove?
Lifespan of the fab stove. Hasn't been there long. Would you want to comment? Yeah.
No, I have just shared the video of the project in India that Paul have talked a few seconds ago.
Yes, this project in India with the Champion stove, and I looked at it last night. Excellent. The presenter is the guy that I work with over there. He's in charge of making this happen, and so do take a look at that. All right, so.
Sorry, Paul, just a quick question about that project in India. You said that they were generating carbon credits. Is that for the biochar they're producing, or is that just from the avoided emissions?
That project is for emission reduction, okay, ER, okay? CDR, carbon dioxide removal, or BCR, biochar carbon removal. That's a European term which I like. They put that in, and it's not. CDR can include direct air capture and all this other kind of stuff, and tree growing and stuff like that. Okay, so the BCR type of thing, they're not utilizing that yet. I am trying to. We're working with them to do it, but that comes in when we talk about finance. Okay, we're going to have to come back to that part. I want to go through finishing this here. I'm trying to convince. There's that information about it. You see that flame up there again. This is about room heating, space heating, and could be supplemental. It's not your main stuff. Again, topics that we can talk about at length in the afternoon and other times. This is the one in the upper right-hand side is in the room here. Oh, it's over there for cooking. Okay, carbon negative heating, large scale, small scale. I can talk about how many BTUs, British thermal units, or how many kilowatts of thermal energy you want. Yes, sir.
How can we scale it? Like, how big can we make
Uh-huh. He's a plant. He asked exactly the right question. A segue to the next part. Okay. I'm going to, this is it's at my website under woodgas.com/resources. Go to the section on heating and cooling, and this chart's in there. I'm not even going to go into this thing. The one on the left is TLUD we've talked about. The one on the right is a different type. It's AVOD, I called it, for another variation, but now it's Anderson's version of updraft. Oh, that for Norway, we want a topic. I want a Norwegian company that wants to do this, to make this thing happen. There's something in what I'm talking about for every different component, and this is not, the AVOD thing is not for Africa. Just isn't even part of or for Asia and stuff. It isn't part of the discussion. Now, the bigger sizes, okay? TLUD in the upper right-hand side there, in the size of a burn barrel, 200-liter, 55-gallon, same thing, barrel, works well for making biochar. You are not cooking with it. We are throwing away the heat because we do not have good ways of utilizing this heat at this time. It's too bad. But if you've got to get rid of the waste, the biomass is sitting there, it's obstructing the pathways and starting to rot or whatever else you want to do it, barrels work well. Thailand, Warm Heart used, like they had 200 burn barrels going at the same time with a bunch of people. One person's taking care of 5 or 10 of them, something like that. And they had a mountain of corn cobs at the corn processing factory. It worked well until somebody else found out that those corn cobs now have value, and since they own the corn cobs, they cut off Warm Heart, and they don't have it anymore. That's too bad. But that's another topic for in the afternoon if you want to go into biochar production at the barrel size. This is TLUD barrel, toplit, updraft, burns through, clean burning, this other kind of stuff. An alternative to that is the rock kiln, ROCC, rotatable covered cavity kiln, the rock kiln, okay? I invented that, okay? And there's a story about that. Wait for the afternoon if you want to hear it, the types of things. It's interesting, and the frustrations and the rest of it. I have a patent, 2 patents, that relate to that kiln. There's one of them over there. We had it on there. This afternoon, we're going to talk about how you mount the wheels on it. I mean, I could spend 20 minutes talking to you about the options on how to put wheels on so that they don't get burned and blah, blah, blah. I mean, we're working on this stuff. This is the experience which I am offering. And if anybody's interested, I'm here to let you know, okay, as much as you want. The patents, it is they're USA patents. I have patent pending status in Canada and the European Patent Agency, which is 41 countries of Europe, okay? Just about everything except Russia. I mean, they're into that thing, all right? All of the other parts of the world, the ability for me to even seek patent coverage and pay the bill every year so that I have patent coverage for Zimbabwe or South Africa or Pakistan. I mean, I'm not going to do that. I mean, I'm not here to try to make any money off of the poorer countries. That's too bad. But I'm not. USA, Canada, North America, and Europe can pay up, okay, in my opinion. But and it should be. We're talking, there's some big stuff. Things are possible as it gets bigger. So the rock kiln technology, and that's a major discussion on how to do something larger quantities. That barrel measures 2 feet in diameter, okay? We're going to get to some pictures here in just a minute. Now, forget about the one on the left. That's the atom retort. We can talk about retorts and otherwise. The flame cap, yes.
Before you move off from that last slide, is it it just a single barrel, and then it's got holes in the bottom and that gap in the top and the chimney?
Yep. Yep. And you can make it even simpler than that. I mean, there's techniques and little ways to make it really cheap. I mean, it's a barrel, and surprisingly durable. And there's techniques. There's lots of techniques that go along with it. The flame cap technology, I also call it cavity kiln. The cavity down below is where you're going to collect your charcoal. The flame at the top, the flame cap, is what's going to create the biochar, going to create that. It's the same name, same process with the name describing the bottom part or describing the top part. Flame cap and cavity kiln is the same thing. And there's some models from it. There's the Kontiki on the lower right. You can do it in a pit. Problems with that. Again, how are we doing on time? Where are we at? It's 10? Okay, just about 10. All right. So, yes, we're going to move right along here. That is it in the afternoon. If you want to make charcoal, biochar, in the sizes of it, that cavity, here, let me go continue on. The drawing in the lower right shows on the partially covered, the arc of the metal that comes over the top and creating that biochar that's down in below. This is the essence of why it works and how it works. For whether it's the Kontiki, like the one up above, or the one with which I have, it's just partially covered. Okay, here's the ones which I have built, among others. Okay, the lower left one is made in Kenya in 2019, before COVID hit. I invented it in the last 4 months of 2019. Before that, I had something that did not rotate, and it didn't work. I mean, I was trying to make it work. That's part of the longer story in there. Okay, but added the rotation capabilities, made it in a barrel. The second one from the left, lower left, that's in India. That one's about 3 feet in diameter, and both of those, actually 3 of the 4 that are shown there have hoods on them, chimneys to help it. You don't need the chimney, but it helps to maybe if you have to control your emissions. This is part of the things that you're talking about, trying to keep the costs low. There's a big battle. How can you be cheap enough? And then somebody says, yeah, but I want this. Well, sure. Double the price and you can have what you want. 10 times the price and you can make electricity with it. You know what I mean? But this is it's unrealistic. You wouldn't do it that way. So there's these pros and cons that go along with this thing. The one in right there is in California, and that's a 4-foot diameter one. There's about 3 or 4 of these 4-footers around in the world, and looking at it. Then COVID hit. That was in February of 2020. Not much happened for a few years with it. I mean, you know the reasons why, okay?
Why?
And that was what?
Why did it lock down?
The lockdown, yeah. I can't talk. I can't go to anybody. Nobody wants to do it. How do I give this information to you if you're all sitting in a mask looking at a Zoom in a different country? I mean, we didn't have it, okay? So this has been a serious delay for this technology to become more available. It doesn't even make the general program, other than a few mentions of it, for the Biochar Academy. It is not part of the small-scale features and things that are on there. I mean, I talked with Kathleen about it, and she's very open about what they're doing and what they're having to do. And I came here because of Daniel. I work with him in Venezuela. I never met him before 2 days ago, okay? We've done Skype and everything else. We've done projects together. Never met him. And it was cheaper for me to come here from Illinois with a car full of stuff than to get him from here to Illinois and then get him back to get his place. It's just the logistics are fine. And I said, if I'm going to spend days with Daniel, I did the 2 days of yesterday's field stuff because I wanted that also. I now have Saturday and Sunday. I must leave Monday. I am not part of the academy, okay? I'm not there for your Monday. You get your questions answered this weekend, or else you're writing emails or calling me on WhatsApp, okay? So I come here with this carload. I have taken carloads of the stuff to stove camps so many times. I've done more than 20 camps of a week long for stoves or biochar and stuff like that. So this is why I said, they've got a Saturday time slot unoccupied. And I volunteered. And Kathleen said, sure. And then we found the room and we got the stuff, and it's coming out much, much better than it could have been, okay? But we didn't get to be allowed to have any fire here, so you can't have a hot lunch. You're going to get a cold. Yes?
Can you tell me a little bit about, because I'm not reading very well, the California unit experience? Is how many kilos you put in each batch?
Sorry. Afternoon. We're going to get back to that. We'll get back with that. The one in the upper right, that unit is 6 feet. No, California there, that's 4 foot. Okay. This one here, that is 6 feet tall. I'm 6 feet tall. I can stand up in this cylinder that goes around me. It is made out of a culvert. Culverts are made for underpasses of water, for highways and stuff like that. Around the world, there's different ways of making them. They make culverts 18 feet in diameter. I mean, that's 10 and go almost again. I mean, it's gigantic. So I am looking at these prospects and stuff like that. Yesterday on the bus, I sat with the guy that was here from Arkansas, and he's interested in something, and it's big business and stuff. I'm not going into the details with you on it, but this could be one that's at 12-foot diameter, 16-foot diameter. We might go it's big, necessary industrial size on it. I work on small scale. If somebody wants to pay the bill for the big one and they've got the need for it and the desire for it, I'm here to help them. First time ever, but the largest one of the rock kilns that's ever been built is a 6-foot diameter. And that's in Illinois and with me, and I would be happy to work with anybody about that unit and build it up and doing something else and things like that. This afternoon we can talk about what's the advantages of pros and cons on those types of things here. Let me get, that's the one from California, the 4-footer. We can come back to these. That's the 6-foot diameter one. There you can see fire inside of it. How much emissions am I getting? I'm getting some. It's not perfectly clean. I'm getting less than a Kontiki, in my opinion. But nobody has had a Kontiki and a rock kiln side by side, same fuel, same characteristics, and what they're trying to do that research. Any volunteers? I mean, feel free wherever you're at. Oh, you're a graduate student. You want to do it? No.
I'm not a graduate student. Are you going to talk about the technology people are using to measure emissions?
About what?
The technology people are using to measure emissions.
Again, I can do that in the afternoon. It can be a long, there's a variety of issues and stuff that relate to it. Let me just, going through some of these things. This is the one that's in Kenya. The wheels, 4 wheels, those are the rims. There's no tires to catch fire, so they just push this thing around. And it has the struts across, the X on the back, the H, we call them an H frame for the end of the end piece there. The unit that's over here in the corner has an H frame at one end, and it has a mobile unit thing on the other. So that is not a typical unit how you would build it, because I can't put all of it in my car to bring it here. Okay, so I brought 1/2 of each of 2 different types and stuff like that to be able to move them around.
How many times can these be used before they need to be completely replaced? Because they're not stainless steel, right?
No, not stainless. The ones in Kenya that were put into use, daily use, probably went 9 months before they were worked on, and it depends a little bit. There's some factors with it, yeah. They don't burn out. Oh, and a very crucial question. The burning of these flames, oh, that's so hot, yes. But what's the pyrolysis temperature? I mean, the flames are 900 centigrade, 1,100 centigrade, okay? What's the pyrolysis temperature? 550. The difference between those temperatures and their impact on metal is drastically different. The bottom part of these barrels are only being subjected to 450 degrees, 500 degree centigrade temperature. That's why it doesn't burn out. This isn't like running, there's no oxygen coming in at the bottom of these things. These are little details which make so much importance with regard to the what can be done and what can't be done. This one, you see the lower right, a tray to catch the char as it comes out, to be able to put it into a collection barrel. We can talk about how we can then weigh it to get our measurements and things done. Last slide of this section here that I've got. I like this diagram. There's 4 major components for how to make money with the biochar industry. Upper left is charcoal products. Upper right is use the energy. Lower left is I got to get rid of this biomass. I will pay you to do it for me. That you can have a viable project on that basis. And the other benefits of chemicals, the wood vinegar, carbon offsets, and climate benefits, they each should be their own separate square. They're that big. The carbon credit item is a subtitle in one of the squares, the same way as the chemicals. This is how big this is. If you're only making biochar for the top one up there to put biochar into the soil, you've just turned your back on 3/4 or 9/10 of the possible income sources. Not all of them will come together, but if you can get 2 or 3 of them to work for you, hey, it's sustainable, it's viable. And that mentions my white paper there. Okay, and that's finished there. Time, please.
10:06.
10:06. Good. Look at that. Fab stove, the barrel, the flame cap, the rock kiln. I got to do a recognition, and then we got a break. Afterwards is char track, the thing, and the testing methods and financial stuff, and then we're going to have lunch, and afternoon is whatever anybody wants to do, stuff like that. Okay. First I'm going to talk about lunch. I have been off. Oh, where's your cap? You got your serious cap?
Yeah.
Bring them out. Okay. Now's the time. Okay.
Right.
The company is Sirius. Oh, no, it's spelled S-I-R-I-U-S. It is the constellation, the stars. The Sirius. Oh, okay, he's got to go back to the room to get them, okay? And they are sponsoring our lunch. They're going to put some money in for this so we can buy a few things. I was going to cook grilled cheese sandwiches on a T-Lud fire, but I'm not allowed any fire. I have also found out that many of you went off on the first day and bought a bunch of food. And it's sitting in your refrigerators and looking around and stuff like that, especially Julio there and stuff. We have a package of broccoli and carrots. Okay, he's willing to share this. So what we need is some dip. And dip is over in Walmart, okay? So we're going to look for a group or somebody who will do the shopping trip to go over there, but we have to find out what we have as available for food or we don't have for food. No sense buying broccoli because we got it. Okay, yes?
We had leftovers from yesterday. Pasta.
Very good.
And a lot of
Vegetables.
Okay. Okay.
I have salad.
And you have salads. Okay. All right. I need, here's my plea, the juntos together thing. I need a small committee, 3 or 4 people, who say they're going to help make the food thing right. What was that, a volunteering or what was it?
We have beers.
You got the beer. Okay. All right, that's fine. That's.
Alcohol you have.
Are you? Is alcohol allowed in the dorm?
In the parking lot.
In the parking lot.
Okay, fine. All right, that's fine. Okay, fine. All right. I need a little committee that's going to help get us down. We're going to write down on a piece of paper that someone who's got a piece of paper what we've got and what we need to complement it so that we can eat the broccoli. We want dips and what type. We want ranch. We want this. And somebody that knows go to the Walmart and need someone with a car to do the drive over there and pick up some stuff like that. If we're eating like 12:30 or 1 o'clock, that's not too late. I mean, we don't have to break off and stuff, but that somebody is going to have this part worked out. Okay.
My wife's work will be chopping. I can just she will just go to do that for us.
Okay. All right.
Louis, you help us with shopping, right?
She'll help with the shopping. Okay, fine. We've got enough people here that are willing to help out. Jane, I'm glad you're here. Jane wrote down when you people introduced yourselves on Monday. I wasn't here. Each person's name and stuff like that. But we do not have your email addresses. They have the addresses for the academy. But there are limits. You cannot give somebody else's email address to somebody without their permission. Okay? So I am going to collect from those willing to do this. I need your name and your address and the key word, like you're going to put down Saudi Arabia, Pakistan with your along with your name and email. So then I've got that. So that triggers me who we've got. And okay, yes, okay. Okay. All right. Here. Look. Hey, folks, isn't that cool, huh? As they say, the guy's name, the main guy is Martin. Okay, as he says, let's get serious about biochar. Okay, all right, it works. Just go ahead and would anybody not want a hat? I mean, you're welcome to have a hat on that. Sirius is in Colombia, South America. What? It's Sirius. No, it's not Cyrus. There's an I in there. Sirius. Okay. Yep. And it is in the. It's a play on words on this some of that stuff. Okay. So we have now the sponsorship for our lunch or for that. Oh, by the way, this food. We don't have to eat it for lunch. We can eat it for dinner. We can eat it tomorrow for lunch. We have to be out of here by noon or 12 o'clock tomorrow. This room is spoken for, but we have it until that time. So as far as this food will stretch out, it's not just for lunch today. I'm looking at if you still can eat the same stuff for lunch tonight, we'll do that. And we now out of Daniel, okay. Oh, okay. He's getting the picture. That's it. We want a picture with everybody with a Sirius hat on, so we can send it to Sirius with thank you very much for helping us with the lunch and sponsoring. Daniel is going to talk more about Sirius on his project day and some of these types of things in it. We're trying to get the information. They are related to a palm oil business, and therefore they have access to PKS, palm kernel shell, which is an acceptable fuel inside of a fab stove. We did it yesterday. We've got this char. We can show you the char and stuff like that. Yes?
Yesterday I was discussing something with you, the char from the virgin pellet to the palm kernel shell. And it can be looked again to see the value in construction. Because in the West African zone, we have a lot of these kernel shells. And as I worked with you on Thursday, I saw that it burned 1.5 hours with flake.
Yes, yes.
With the palm kernel shell.
Palm kernel shell.
1.5 ounce.
Yes.
That's not bad.
There's another list here. That's called, you've got that on there. No, I'm just going to say it, and we're going to write it down or something. And about Sunday, there is an interest here by Kathleen Draper, who is interested in how you can put biochar into construction material. We have in our presence here a person who has expertise on construction material. Nothing to do with biochar, but this person he or she happens to be here. Kathleen Draper is interested in, can we put biochar into this construction thing? And they've asked to make a description on it. Okay, I am volunteering that for the whole group, if we're interested in this, we will join it. The person is Daniel, and his technology is called rammed earth. And it's not Adobe. There's a technology and stuff. You're going to present about that. You're going to present about that on Sunday. Okay. Yep. I'm asking you now because Kathleen wants to have a builder guy, a friend, come by, find out how do you make the mold to do the rammed earth, and then we want to do the rammed earth, some with biochar and some without, to see the impact and what can happen. Are we able to store that part of sequestration, the storage component in the sort of forever context, into rammed earth construction? Cool, interesting. I'm proposing that it would be Sunday. You'll talk to Kathleen.
Yeah.
And
Let me say
go ahead.
This is something, thank you very much, Paul, for introducing that subject here with all of you. Sorry. The thing is, Kathleen and I'm trying to figure out how to make this happen. I'm in touch with this guy, Dave.
Dave, okay.
The man that built her house, in her place. I don't know where it is. We need to build some tools that we needed because it's not something trivial, like it's very important, the form work. So we are just dealing about it. So at this time, we don't know exactly what's the date, but for sure, it's something after the academy. It's not within the days of the academy. I don't know how many of you are able to stay those days. I think we are going to
Okay.
your volunteers.
Okay. Now, camera is on, right? Good. All right. On my here before the break, recognition, unexpected. Nobody knows what, but I want you all to be participant in this. I invite Daniel to come here, please.
Okay.
Oh,
Thank you.
you don't know what I'm doing, do you?
No.
Oh. Watch his face. Watch his face. Daniel, I'd like to give you this present.
Thank you very much. These are the green, green awards.
Go ahead. Pull it out. He has never seen this. He's never touched it before.
Yeah.
Okay. Okay. Get it out and show it here. Okay. And save that wrapping. You got to take it back to Venezuela. Okay. Yeah.
With me, please.
Yeah. Okay. Do you want to tell the story, or you tell the story? I've talked enough. Go ahead.
I'm gonna try. The thing is that, the way that we met each other is, this is our first time in person, but I reached Paul because I was working with my prototype of clean cooking chilled gasifier. Sorry. So we started work. He was very interested in know my knowledge and my experience. So we start sharing information, and I realized, or I have some information about this organization that is that they are working for 10 years. I think
right
9
now.
or 10.
Yeah. Premios Verdes, Green Prize.
Yeah.
Okay.
It's for or Latin American word. Well, also there are some Spanish people like they work with Spain and Portugal. That Iberoamerica is the name. I don't know what to say that in English. But Iberoamerica. So I just wrote a proposal for participating in these awards. I did ask any question for Paul. I just submit the project, and I told him when we achieved to be finalists in two different categories. So we start the process, because we have so many meetings with what's the name of the people that study our project, the
evaluators,
the juries. So at the end of the process, we won 2 prizes in the 2 categories. The first prize in 2 categories. And he was
Premios Verdes in Latin America. They've usually had their award ceremony in Ecuador or something. This is last year's thing. They had it in Miami, okay? And I was part of the team that did this, and we got into 2 categories, one of which is clean energy. That's what this one is. The other one was sustainable development, or the sustainable project like that, okay? Never before has a project won 2 categories in the same year. Sometimes someone has won one and then he came back another year under a different category and they did something like that. So I have one of these at my house. I brought both. I got to go to Miami. I got to go up on the stage to get these types of things in the name of both of us and stuff. And he hasn't seen it yet. He had to touch it yet. So now I want to explain something which is, that looks like a couple leaves and stuff, and the label is on the side here, but I want to turn it around this way. North America, South America. Actually, I think they put the label on the wrong side, but it was nicer on that way. The way that it was made, this is handmade in Ecuador. They got these, they presented them and stuff like that. So I've got one at my house out into there. So it's a nice trophy and shows what some ingenuity and perseverance can accomplish. Thank you, Dan.
Thank you for your support.
Your suitcase is going to be so full.
Yeah. The issue is MRV or MMRV, measurement, monitoring, reporting, and verification, okay? Certification, that's what somebody else does after they look at the verifiers and all that stuff. But how do we get data in that can be with confidence, okay, that's going to be defendable? Blockchain is a technology which has immutable records. Big talk about it. It's used with cryptocurrencies and stuff. We're not into cryptocurrency at all in this stuff. We're using these characteristics on it. I've been after this for many years, and I work with a fantastic, extremely smart computer senior software engineer. There's different terms and stuff about it, what he does. He knows the hardware stuff and things like that. We're partners in this thing. So, but I'm the front end out. He is really quite off the scene. And part of what it is you should be operating with a system on your app or on your phone with the app and stuff where you do not have to interact with the software engineer, the person that's running it. It's done automatically. They just keep the system going. They solve some individual problems. So, should not have eaten a carrot without water. So we have a little demonstration, and I need a volunteer who has a smartphone, knows how to use it, is willing to use it. We'll put their email address into the CHAR system, knowingly that you will therefore be eligible to get a renewal notice, or get not a renewal notice, but get a notice of updates and things like that. This is part of how it will happen. I want to do it with one person first, everybody watching, and we are able to do up to like 10 if we needed to, okay? This is a fake effort.
Cheyenne wants to work with us.
Thank you. And what?
No, that Cheyenne was volunteering.
Okay. Excuse me again. Your name is what?
Cheyenne.
Cheyenne, and where are you located?
Maine.
In Maine. Maine sounds as good as any other. I mean, it is in Africa, but it's Shane, tell me just a little bit more of what it is that you work on relating with CHAR. Your CHAR production?
I work for NRCS, so I don't know if you want somebody else who does production.
I think we almost want someone who's got a production line of things. Okay, is there somebody that does production? You want to fake it? You're not Jane. Jane's the other one. You're Cheyenne.
Jane's right there.
Hi.
Yeah, but okay. So we'll go with Cheyenne. Fine. All right.
You can settle up for me.
Okay. No, this is fine. I do not have a way of showing this on the screen unless somebody can figure out how it's going to happen on here. But because we want it done on your phone, not on a computer. You need to have to log in. You have Chrome, please. Okay. Logging and.
Somebody knows how to put a Bluetooth with the TV. I am from a different.
There's no AirPlay on it. Yeah. And no one has a HDMI to an iPhone cable.
Okay. All right. So some of you're taking notes as to the types of steps of what it is that we're dealing with. Let me get my page. I have two clipboards. And then if anybody did not sign on this, that's my pen. Their name and email on here. Let's make sure that gets on. And so just keep raising your hand, handing it around, and getting all that. Okay. The name of the website, and Chrome is the better one to use on it, and this is in development. You want to go to chartrack.com, okay? I'm going to put this over here. Okay, CharTrack. Thank you. I've got one. So I'll not open a second one. Okay, CharTrack. In the computer world, you don't put capital letters in there, which is fine. But please note that it is not chart rack. It is CharTrack. Okay, so we always spell it out CharTrack, looking like that. Okay. www.chartrack.com. And this is, and the setup is the following. Somebody owns a project. Probably you people will be project owners, okay? In this case, I'm the project owner of a dummy situation set up to do it as a demonstration. So to be able to become a CharTrack user, you have to have a project. You have to have an entity, yourself or some company, and that information gets logged into the system. We know who owns it. And if you own a company, you want the company's name as owner. You become the administrator. You're the chief operating person for that, for the data collection, because it's the company, not the individual. Just keeping those sort of positions different. Yo, it's my company. Right.
The company, because here we are several from different countries. Do we have to? Is this company need to be America, European, from this country?
No.
It's a society, SRL.
No. Okay.
Could be a person.
It could be a person if that's the entity that it is, but then you have difficulty transferring your company to somebody else if you do a partner or something else on it. Your project becomes owned by somebody else. They don't own you, okay? They own the project that you started. So we're taking it as this is your project and your name. For Daniel, it is Juntos Biochar, okay? And Daniel is then the person in charge of Juntos Biochar. Even though he owns it, he controls the whole thing. But this is way we know what this is. All right. And the project is going to be asked, what's the basic types of things, and we need some characteristics. We want to be knowing, what kind of biomass types, plural, are you going to be using? And what kind of kilns are you going to be using? Because you do not want to have your biochar from type A fuel with type M kiln mixed in with type A fuel with a different type of kiln, or type B fuel with M, and these combinations. The software keeps it separate, because in the end, when somebody is paying for and buying their carbon dioxide removal credits, this system is going to be used to calculate back through and say, you got the char that was made in South Africa in this time period in there, using the properties of this particular company, okay? You do not have to have an even solid, round number of tons of carbon dioxide equivalent. The computer will be taking care of also the calculations subject to the parameters that you have of testing. How much carbon dioxide equivalent tons you're getting in relation to how many tons or kilos of biochar that you put in. That's just calculations inside. Your char still has to be tested by somebody, okay? And then they're going to say your char is 80% fixed carbon, or 60%, or 50%, some number into there. That number gets in, and it's going to be put and calculated in. I'm saying going to be because that part of the program isn't fully developed, but that's just inside the workings. We're going to show how you will actually put data in. Yes?
If this is a website, we could do it on the computer so people can see, or is there a reason why?
Some mobile phone device.
It's set up for the mobile, and I'd like to not try to do it that way. I understand what you're saying, but we're trying to have this is a first time ever demo of something which eventually we're going to be having people that you'll be able to take this back to your home country, and you'll get a barcode, or you'll get the thing so that you could do it and show it to your coworkers or your other people. This is before you become an actual project. When you become an actual project, then you have the control, and you can run it off of a tablet or off of a computer and the other things.
Should I enter demo mode?
Is that what it says?
There's an option for demo mode?
Yes, you'll go with enter demo mode. What were the other two options? You're the communicator to it. What are the other two options?
One of them was use my location.
Okay.
Show my location, erase cache data, enter demo mode.
Okay, all right. We're doing the demo mode because we're sitting here in a building. We're not out there actually collecting char someplace else, okay? If the others you want to look at it, it's chartrack.com, but she's going to be the one that we're going to go through with that. Okay. Now, go to the demo mode. You're in the status there. charcoal collector. You are going to be a charcoal collector with an ID number. This is your project. I own the project, or I'm the administrator of this project, and I have Daniel as my assistant into there, and there are people underneath him who are doing the actual work going out into the field. That person, like their ID number, they got a card with a barcode on it, so we know who they are, so they can't go fudging. You don't want to be fudging around. You know, somebody typing in other people's names and things like that. The credibility is a very important issue. But I will say, if you want to cheat, and there will be cheaters, we have to watch out for that. We don't want that to happen. It spoils the reputation, spoils everything associated with it. But and you have to have trust that actually Cheyenne is going to enter the real numbers that it happened of how much char you created, not that she's making up numbers and stuff like that. If that's the case, we'll find you out and then we'll fire you, from the project, because you have to do it. That it jeopardizes the whole thing. So we're going to put you down as this one here, as a charcoal collector.
So you want me to scan it?
You're going to then scan that upper right hand one there.
Okay. Validation code?
That is, oh yes, now, All right. Now you need a validation code that can only come from the system or the owner of the project, and that's me, okay? So the number for you to use is 7813. The other people, please do not go putting those in, because we're now doubling over and stuff like that. And the others didn't scan it. 7813, yes?
It works.
What did it give you?
Now it's asking for my name and email.
Your name and email. You are going to put in your first name and last name as real person, and your email address, because you are giving permission for us to communicate with you in the future also. You're going to go into the database. All right? So she is now becoming a registered user in it. This is not something done every time. The next day, if she's going to be a charcoal collector and going out day after day after day, she'll just scan her card and the name pops up, because it knows who goes with her card number, okay? So you're into it, and what does it say?
It is asking me for a biomass type.
Biomass type. Does it give you any choices?
The options are coconut shell, palm kernel shells, or other fuel.
Okay, coconut shells, palm kernel shells, or other, and this list is in the database, and only the biomass types which are in use in your project will appear on the screen for this particular collector. The database of all possible fuel types is big. This is inside of the whole big system of CharTrack. We in Kenya are using things called hedgerow trimmings, okay? They're cutting things down on pathways. We've used sugarcane field waste. We have yes.
What if you want to put corn cobs, for example?
Okay, yes, it's not
How
in.
do we do it?
Okay, it's not in there yet.
Yes.
It will be put in by the administrator, the person doing it. She gets only to choose something that we have.
But we can go to others and write it down, because there is an option others.
No, I don't want to try that at this time. We're just going to take one of them in there. Okay.
Does it matter which one I choose?
Let's go.
Choose other, just
No,
to check.
This causes
It's not
problems.
going to
This guy
explode.
causes problems.
It's
No,
not going to explode.
no, we're going with
Going with
palm
something
kernel
else.
shells. Okay, palm kernel shells. Okay, and then what's next?
Enter scale reading in kilograms.
Enter scale reading. Okay, somebody is out there. They've done their run in a rock kiln. They've collected fuel from fab stoves for a month, and they've got this char that's in there. You are the char collector. You're at the household, and you're going to then say, show me they bring out the char, and it is, and what they do in India, they literally spread it out on a tarp, on a cloth or a thing, and they check it. They don't want something soaking wet, and they don't want something which has rocks in it. and they don't want something that's hot. And this is a physical check by the char collector, looking at it, and they pick out the pieces of this. This is a piece of wood that is not sufficiently charred yet. We take it out. They can burn it another day, but they don't get it counted as that day's char. Okay, so we gather this char together, and we put it into a container. It can be into a sack. It can be a metal bucket. It can be something like that. We are going to we're going to get the weight of the empty container, and we're going to get the weight of the empty container with the char in it. And those are numbers that you actually see, and you never push the tare button, the zero out, because we're always using the actual full-fledged readings. The computer takes care of subtracting one from the other to give you how much char is in there, okay? So, we have to imagine here. Let's assume that you're going to get, so it's not my number to make it up. Give me a number somewhere in the range between 15 and 30 kilos, and you could have a decimal point in it for at least one digit. I choose at random, please. What? No, above 15.
Above 50, sorry. 55.
What?
15.
15.
I'm doing 15.7.
15.7. Oh, sounds good. 15.7. Okay. All right. And you put that in. What does it say next?
Take photo.
Take a photo. I have, let me see here. I could just, yes.
I have a question.
Yep.
So the scale reading,
Yes.
this is supposed to be the weight of the chart and the container?
And the container, yes. Okay. You stand up here with me. All right. You're going to take a picture of the two of us, and we've had our scale, and we're reading this thing. It says 15.7. Okay. Take a nice picture. Smile. Got it? Okay. That has now recorded this event. It has also recorded who we were and where we were at. It has also recorded what is the GPS position of where we're standing. And if we went over to that corner and did it again, it's a different GPS. And it recorded the time down to the seconds of when it was taken. So if we're in that corner over there, the time changed also. You cannot cheat in this system for getting it in there, okay? That's what we have in there. So you have a, and so you took the picture, and then there's a button that says what, collect, it's an orange button.
Upload.
CU, okay, CU 90707, which is this one right here. Okay, that is provided. Okay, you are the collector. I did it. I got the collector right. Okay. So that is that you're going to select that one there, and if you wanted to take a picture, it would show it. This is the card that the cook stove user has. The person that's been making the char, they will have their own card, or it's just entered in. Because when you're out collecting, you're going to go house to house to house, or kiln, whatever it's going to be. And because it's a sequence, the second time, third time, the 50th time you're doing it, it's the same thing. And the computer knows which is the first time through, this is going to be the first household. Okay. We're sort of establishing our route for collection. Okay. All right. Yes. So click that number, not the pair, it's that one. And the photographs become available for the verifiers, and they could say, hey, were they there? Were you there with Anderson when we took that picture? I mean, your word is what's going to be making sure that this is a legitimate thing. Yeah, I mean, you can take it in different ways to establish your credibility. Yes.
So what exactly does it track through the process? Does it track just the collection, or is it the production collection? Does it also track the end of life, the burial?
Yep. The process functions with you're getting production put in. A concrete example of the rock kiln in Kenya, and we're using the biomass. That size of a rock kiln, double the length on it, will produce 25 kilos in one run of about 4 hours. So they do 2 runs in a full day, becoming approximately 50 kilos of biochar produced. Okay, so 50 per day. That is one person with one kiln and using one type of biomass. There could be other people with other kilns working alongside of them, and they've got their own users. They're collecting up, they're putting in the data. They weigh this because we weigh it dry. We don't have to put any water on it, and that way it's a better valued, it's a more trustworthy value, because otherwise you can't prove how much moisture is really in it without other testing and stuff like that. But if you put water on it, you would have to identify it. Water on it, and then there's a question on the humidity. I'll make it 3. 3 kilns operating, each one with 2 runs in the day, makes 6 runs in one day. They're all working in the same area, the same agricultural field. It is, we were doing it with sugarcane, field waste. You can do it with corn stalks. You can deal with whatever the trimmings which were done on there. The issue of who cut the stuff and put it there, that is separate from it. You're expected that your biomass going in is dry. Otherwise, wait a few days before you go and do it. Those 6 runs, 2 runs each from 3 people, we're going to dump it in one spot. The conceptual name we put for it is a pile. This pile is going to have approximately 6 times 25 is what, 300 kilos of biochar in that pile. And we drive a stake in the ground. It's got a number on it. We can take a picture of that pile and that on there. That's just one day's production. You can have the second day, if you're in the same area, if you want to add on to it onto that same pile, it's allowed. That's fine. You are determining when the pile is defined. It is closed, no more going in, and not taking things out. Obviously, that's cheating on the system. Okay, so you've got these piles there. If you are going to transport that pile from this spot over to that corner over there, or to the next field, or what you're going to do, that will be, it's not in there yet, but that will be a transaction that you're going to say, I am at this pile, I am taking it from here to that location. You take a picture at the second location, and that's going to give the GPS coordinates where it's at. You can also be bringing multiple piles together, and you could end up with 2 or 3 tons of char in one agglomeration. Okay, we're looking for in different languages, they'll use different terms for it, but that agglomeration into there, you are tracking that amount of biochar that came from multiple piles, that came from the 2 runs from each of 3 of these things over multiple days. That's all into there. Next is a modification. You will put in, we're mixing this char with manure. Okay, first of all, this char has been rained on out there. Okay, we don't care. We know the weight of the dry char that was in there. What you're doing to it inside is not something we're going to try to track, because it is a real hassle to try to weigh these piles of manure and everything else in it and stuff. We build it up into there. It's aged, it's done. The transaction is going to be dispersal of this char. You have made it, you have to get to the point where you're going to declare that this char is stored, is sequestered, is distributed, it is irretrievable. And that could be at an action of it. We took it from this to Farmer Jones's field, and in Farmer Jones's field we spread it over an area which you can even define with geographic coordinates, but not everybody's trying to do research, but you're spreading this stuff out, okay? So that's the cycle of this char from production all the way to the distribution. If somebody said, I'm doing research on this char in that field, this becomes their starting point, but that starting point has nothing to do with the carbon credits that came afterwards. If they said it came from this field or this forest of bamboo over here, and that was taken down, so that is recorded in it, but that was prior to the char being produced. So we're working with the char and we're tracking that. That's what goes through. That's the rationale behind how CharTrack works. Okay.
So I have a question.
Yes.
So this is for carbon credits.
Yeah.
Right? Yeah.
Carbon removal credits.
Carbon removal credits. So are the companies who are paying for the carbon removal credits, are they going to accept this as a tracking system, or how do they? Like, what is the system already that people are using to track these things?
Okay.
For the removal credits.
We're discussing here the process of tracking and being believable data. Okay. Many projects on the voluntary market are saying, and they got a super sack of biochar, and they don't even track where it all came from, how many places, but they came out of this, they've got this quantity, and they have a weight for it, and they put a carbon future tag on it or something, and they ship it over and they spread it out someplace, and they say, we distributed this super sack and over there, and it's worth 7 carbon dioxide removal credits. Okay. There's their evidence. This is what they're saying, what they did. Some of them, Carbon Future does have a tag which can be scanned so that you know that this bag was moved from here over to there. Okay, that's nice. It's for the developed countries where there's enough money and all the handling and these types of things. You can't just pick up a super sack of charcoal by hand, even with multiple carriers. I mean, this is difficult. So and so they are getting their credit. They're getting paid for this. Many carbon removal credits are pre-purchases. Some entity says, I will do this much char production, giving me that X amount of carbon dioxide removal. Pay me the money ahead of time. And they're doing that. They don't have any proof. I mean, they have the word that these people are supposed to do it. And they get like 2/3 of their money or something like that so they can help pay for this thing to happen. And that's about the stage of where it's at. Other programs to try to track char, not char track, tracking of char. In Thailand, Biochar Life. What is it? Yeah. Biochar Life is working on a system which I would say is to be a competitor with CharTrack. And the degree to which it has the same capabilities, how it's handled, and everything remains to be seen. Dylan Maxwell, a Canadian fellow, has his program, and he is working on, I would call it Charbox or something. I forgot the name on it actually, but his system, their people are supposed to take a video of what they did, submit this video, and he will make a payment to them. Has no blockchain, doesn't have a comparison on it, but on the credibility that this person did it, some money got sent to them. To scale that up, extremely difficult. I know Dylan. I talked with him, a friend of mine. All right, so this is one of the other ones. Another one is, and I'm not too sure to what extent it might be Biochar Life again. Penn State University, and there is a project called Plant Village. I mean, you can search that out on the internet. Plant Village, and they are doing help in, especially in Africa, with regard to helping farmers and their crops and stuff, digital technology, but their focus is not so much on the carbon credit, somewhat on that, okay, but they have a plant identification system on your phone so that if you're seeing a plant and it's got a disease on it, it will help you in the field to identify what it is and help you understand it. That's some of their big picture. I don't deal with that at all, okay? But they are also interested in the char, the tracking of char also in with that. Have not seen their product. Most of these things are, yes, coming next month. And, you know, that frequently next month's become a long time. Yes?
So something that I think is still slightly unclear to me with these kind of large decentralized systems, let's call them that. Who is the person that is actually eligible to claim a carbon credit? Is it the producer or is it the person bearing it? So, for example, is it a farmer that says, I'm going to stop using chemical fertilizer and I'm going to start bearing biochar to minimize I'm going to change my practices. I'm going to start bearing biochar to reduce my carbon footprint and I'm becoming, and I'm generating carbon credits? Or is it the person that is preventing that biomass, the waste biomass going to another use and charring it that's eligible for those credits? Because I can understand in a more centralized production that's in control of it all, that there's carbon credits getting produced. But in a decentralized system like this, yeah, is it the person bearing it or is it the person creating the char that's eligible for the carbon credit?
Somebody is eligible.
Yeah.
And the people who are contenders for it's mine or it's yours type of thing, they have to work it out. And the India project is the everybody signs on when they're getting their stove, the Champion stove, at a discounted price. And it's a favor to them, something that they like to have. And they sign on it saying, I give the carbon credit rights for what the biochar from this stove to the project name. It's a written document, signed or a thumbprint on it or whatever they've got. That is the basis for Atmosphere to claim it, okay? Then, for the most part,
and then it would be up to the project developer to design the benefit sharing mechanism.
Yeah.
However they see the most fit for that particular project. If it's the farmers bearing it or if it's the people producing it or whatever. Or both.
In the case of the cook stoves require some maintenance. They want to have the support and things that go with it. To have that maintenance, to be in the project that's going to make sure that the stove is working, okay, and replace it if it doesn't, or the things like that, then they have to sign. You cannot go to the supermarket or a place and buy a stove, and I'm making char on it and saying, haha, you got to give me carbon credits for that. Not in CharTrack, you can't. You didn't sign on, because you want to use CharTrack or any other product on it. You have to agree to the rules. We're not doing this so that you can get a check for $4.20, and it's a lot of work that goes into that. An example from India, and the conference paper is written up about case study of Deganga in India, where now there's 100,000 stoves, more than 100,000 stoves. And in the past, when I wrote the paper in 2016 with some co-authors, there were 11,000 stoves there. The numbers stay the same. $40 for the stove. They're doing it. They're making the char. The char collector goes out, and they are collecting the char and taking it to a central place, and that char is sold for burning. It is sold for burning by incense stick makers, restaurants that need it, and people with forages and things like that. It's going to be burned it is not a carbon dioxide removal project, okay? But they get credits because of two things. They get 2 carbon credits because the people are using less fuel. The stove is more efficient than the way they were burning before. 2 carbon credits for that, emission reduction, okay? And they get 2 carbon credits because the charcoal that was produced replaces traditionally made charcoal or coal, which people were using in their cooking or in their incense sticks and things like that. So they end up with 4 emission reduction credits for each stove in use. That project wants these stoves in use every day. If the stove is broken, the cow steps on it, or whatever the thing is on it, they actually, because they know the char collector's coming by, they can get a replacement stove within the same day or within the next day. Usually that's the case, okay? These thousands of households are relatively close together, so that you're not like somebody who's 500 kilometers away and you're trying to go get some char there. I mean, the charcoal collector goes to 20 households, 25 households in a day, and they have about 300 or 400 households total over a 4-week period that they go around and they collect into there. They got their own route. They're going through it. The people know they're coming, on what day they're going to do it, and they're going to collect it. So they are then claiming, they're saying, is this stove in use? Yeah, we show it's in use because we've collected char every day. They're not in any blockchain keeping track of it, but they've got these bags of char coming in. A truck arrives from the purchaser, the incense stick maker, and they load these bags. They quantify them into 25 kilo bags stitched shut. So then they can count them by bags, and it's just as they're putting them in. So the guy buys the char. He opens one, checks it out, makes sure it's not all wet. I mean, that's for good business purposes, okay? And he takes that char and he goes and he's making incense sticks. On the basis of what I've been describing, atmosphere, F-A-I-R at the end, not atmosphere, atmosphere, okay? A German NGO, I think I don't know if they're semi-for-profit or something like that, but they are selling carbon credits, emission reduction credits, to offset people's airline travel. And you can go to their website, and you took a plane here, and they'll even help you calculate how much was it from Bangkok to Rochester, and you say, and you have 5 carbon credits, and we're selling those carbon credits at $8 a credit or $12 a credit or whatever their price is, okay? And you pay 5 times 12 is $60, and you put that in and you pat yourself on the back and you offset something. That's not the same as emission reduction, but that's not the same as carbon removal, but it is the established emission reduction type of thing. So they don't have blockchain checking on that. It's on the basis of for 100,000 households, they have like 400 charcoal collectors. For India, you can verify it for me. You cannot hire a person to collect char in India who is of a elevated caste, the elevated level, because to put your hands on that char and the dirt and the type of stuff, impossible to do it. You don't want to be doing that. So the very poorest, the untouchable caste, or to the extent it's banished, they're not supposed to be doing it, but the people very low caste, they take this job. They earn their money and they go and they do it. They go off, and every household, when they are buying the char in from the lady, okay, it's almost always the lady of the house, okay, and they weigh it, and they're paying, last I heard, I think it was 11 rupees per kilo. but it's about 9 rupees a kilo. It's about, I think it's about 11, 12 cents a kilo for what they're doing. The amount of char that they're producing, they're getting a payment of $3 to $4 in a household. Households, different amount of char and those things. That lady receives that money paid on the spot. You cannot expect the poor people of the world to wait until we've sold our carbon credits. This is why they sign away their rights to it, because there's no way they're going to get any money back for their things for a long time. It's the time of carbon credit business to get functioning. A great story of this is they asked these ladies, instead of paying you $3, $4 each time when I come in here, okay, we could come every other month and I could pay you $6, $7, $8, okay? And the lady says, nope, don't do that. Because if I ever had $8, my husband would take it. And that's a social statement which hurts in relation to equities and things and gender biases and stuff like that. But it's a true story. These ladies get this money. It's pocket money for them, pocket money. They buy medicines, they buy school uniforms, they take care of their kids, they do their stuff. It elevates their status in terms of the money economy to that type of thing. So we want this. This is shown to be functioning. Now, what you need to know in terms of the carbon credits, and this is part of the financial element down into here, carbon credits, emission reduction credits, are in the $8, maybe $12 bracket. Sometimes somebody you'll see $25, but it's unusual, I think. Still fairly low per one carbon credit. The stove was getting 4 of them, 2 for the emission, for the less fuel, and 2 because the charcoal was used for an alternative. Okay. Per year, yes, per year. Okay. And distracted myself here. Yes, okay. Instead of those 2 for the charcoal that are going to the incense stick makers, you can get carbon removal credit of 1. 2 went to 1. Hey, that's not so good, right? Except that 1 is selling in the price range of $100 to $400 as carbon removal credits, depending on who is supporting it and what they're doing. I will not sell a carbon removal credit for less than $100 that is derived from one of these, from the developing countries, because I would call it climate capitalism. Okay? It is taking advantage of people who are so poor that, yes, you can talk them down into not $100, but down to $80, $60 for it. And they need something. I don't believe that we should be doing that. So I am not in favor of ever having the carbon removal credits for less than $100. Most carbon removal credits are in the neighborhood of $250 and $400. If you're doing carbon dioxide removal from DACs, from the direct air capture, on the promissory note, advance payment, and you're going to get it, they're selling it for $600. That's a whole different story, and not something that I'm getting into or recommending. Okay, the direct air capture is another whole side of carbon dioxide removal. Okay. Question.
If the market is paying $600 for the engineering carbon capture and storage, why don't they pay the same amount for this that is moving labor? What is the strength in the market?
Okay. The rationale of supporting these companies that are developing new technologies, that are engineered, okay, and they are looking at investing into the businesses and owning part of the businesses. And if they don't get their $600, they can't do the research. And so instead of giving you a grant to do it, I'll pre-buy something that I hope comes along. And when it's Microsoft or Stripe or some of these other agencies which are able to, that are funding it, this is part of their purpose for helping the world, okay? And they'll pay that $600. Yeah. Yeah. Okay. Okay, what do we got for time again?
It's 11:51.
11:51. Okay. We can come back on to a number of the financial topics, some that we've just been talking about that. I want to take the 9 minutes, okay, for the biochar characteristics. Chartrack.com. I'll just use on the same one in here. Low. Volatile. Stable. And ash. Okay. When you are dealing with characterization of biochar, the variables are how much moisture is in it, how much of it is mobile or labile or volatile matter, okay, that's not stable and fixed. Okay. How much of it is the stable recalcitrant or fixed carbon, and how much of it is ash, okay? In the afternoon, I'm going to give you the details from Dr. McLaughlin and his presentation and stuff. But the basic position is this. Oh, I'm sorry. 3 groups here. We have IBI, EBC, and BBM. Okay. The testing of a char, you've already had the lecture of this from Akio, right? Or Akio, I forget how his name's pronounced, but and so they've talked about some of this, you're understanding it. The IBI has a set of standards and set of temperatures that you're supposed to process it at. The European Biochar Consortium has some different temperatures. They're not the same system between the two of them. Dr. Hugh McLaughlin is a world expert on charcoal. He works his whole life. He's just recently started retiring consultant now, PhD, physical chemist, chemical engineer, okay?
What's the name of the doctor?
Hugh, H-U-G-H, McLaughlin, M-C-L-A-U-G-H-L-I-N. Hugh McLaughlin, with the L is usually capitalized also. Hugh McLaughlin, okay. He lives in Massachusetts. A friend of mine, know him well, these types of things. He is saying these temperatures give us some variability that we really need to understand, maybe adjust some systems and things like that. So he put this thing together and then it was basically ignored by most people. It's not in practice. But his video that we can look at later in the afternoon, talks about this. I'll give you one example. You start off with char that's been quenched with water. It has moisture in it. I don't care how you put it out in the sun. They're going to dry it in a furnace, in an oven. It's like a toaster oven. You can do this in a toaster oven, okay? And you need a very good scale for it on it then. A balance scale, weight scale. The IBI, I believe, says 105 degrees Celsius for the drying temperature. The EBC, I don't remember that number, but it's something, it's a little bit different from into there. McLaughlin is saying you should dry it at about 140 centigrade. Why? Because, I mean, this is above the boiling point. There is interstitial water, there's stuff that's kept inside of there. So you do it, you have the same stuff. One of it you go to 140, the other one you go to 104, 105, okay? The 104 one weighs more than the 140. So therefore, that's your starting weight. That weight is going to be distributed as volatile matter, fixed carbon, or ash. It's part of the number. It's out of the 100%. How important is the drying weight in the thing? Well, it could throw you off by 10% in your numbers. That's in his video. He will talk about some of those issues in there. Okay. So just in drying, we take a look at that, a possible error. McLaughlin and I am a co-author with McLaughlin on a paper called All Biochars Are Not Created Equal. If you do a Google search on all biochars are not just that far, it's going to come up with it, and you can find McLaughlin, Anderson, Shields, and Reed, the 4 co-authors on this paper. It's 20 pages, and it's got diagrams and analyses and a bunch of stuff that was done in it. McLaughlin's the lead author. He's the chemist. I was doing stuff with a champion stove, thermocouples, run it, doing the data coming in. Frank Shields is now retired, but he was the key man in the laboratory of Control Labs. And in America, Control Labs out in California is where people send their biochars to be analyzed. Okay, that's the sort of the standard main place for it. So Frank was very, very prominent in this, and Dr. Reed was my mentor on that. So a proximate, it's called proximate analysis. Proximate analysis has been around since the 1800s or maybe the 1700s. It is a measurement associated with the coal industry, because coal going into making steel and things, you have to know what its characteristics are. How much of that coal is recalcitrant carbon? How much of that coal is volatile, the carbon, how much of that carbon is volatile? If you heat it up, it's going to come off again, just like the other heating it up. And that doesn't give you the heat for the furnace. And I mentioned earlier about coke and how you need this blast furnace temperature onto the carbon itself. And so, and then the ash part that's down into there. Biochar is not coal. Biochar is going to be created at a temperature 550, nice number a lot of people talk about, 550 Celsius for the char. And that char will have some fixed carbon, it will have some ash in it, and it will have some other stuff which, once it is heated above 550, or above this, whatever this temperature is, it will come off as volatiles. But your biochar into the ground will never be subjected to a temperature as high as what it was produced at. We're not dealing with coal. We're not dealing with something that's going into a blast furnace, into a furnace to then drive off the volatiles and burn them and stuff like that. We're going something into the soil. So McLaughlin prefers the name mobile matter. This is the stuff which, if water goes onto it, it's in the soil, and it gets washed away, it gets leached away. Some of these are calcium carbonates, which are, there's carbon in it, and it's calcium, and it's important part of liming for soils and stuff like that. But it is certainly not fixed carbon. It is not the stuff that they're supposed to pay you for the carbon dioxide removal, okay? So we like to say mobile. You can say volatile, that's fine. Or some people say labile, okay, is another term for it. Similar concept on it. Labile. Labile. The other one here, your recalcitrant char or recalcitrant carbon, okay, or fixed carbon. We like to call it stable. Going into the soil, it's there to stay. It's the stuff that's going to be there 100 years, 400 years, maybe 1,000 years later. It's the type that has a half-life of X number of centuries or whatever it's going into. That is the stable carbon or recalcitrant carbon or fixed carbon, depending on whose reports and stuff are coming out of it. That is the other group. Ash, on the other hand, are the inert materials, which are minerals and things, which are left inside. If your ash includes calcium carbonates, you can wash that out with water. So do you want to weigh the weight to become part of ash, or should that weight become part of mobile matter? The way that you calculate and determine how much is stable is the following. First of all, it's got to be dry, and we know we even have a different definition of what is dryness. But if you have the dry sample and you subtract the mobile part and you subtract the ash, by subtraction you end up with how much is stable. So anytime that your system is measuring the char at a different level, something into there, you are altering the possible percentages of what comes into each of those three parts, disregarding the issue of the water part. So McLaughlin gives a much better explanation of this than I do in his discussion on it, okay?
Is his discussion on YouTube?
It is on YouTube, yes. It is the Green Carbon webinar series. And you'd have to, under McLaughlin's name, I don't remember which year it was, within the past 3 years. Green Carbon. Yeah. And we'll call it up on the computer this afternoon, or anytime somebody wants it. So these three systems are compared by McLaughlin, and he's saying you have to be careful about what it is you're dealing with. One element is, if you're doing it one way, and everybody knows how you're doing it that way, if you stay with that way, then everybody knows just how good or how bad it is, but at least it's the same. The worst thing is if you're out there and you're not consistent in your temperatures and when you're doing this thing. I have here, I have a scale. This scale here measures down to hundredths of a gram. It'll only take, I think, less than 2 kilos, okay? But it's giving the weight down into grams 0.00 on there. Not ultra expensive, but something if you want to be testing your own chars and things, that type of a scale versus one which is more a simpler scale just to the gram. The types of testing that is done, and this is these. Okay, I have here one. This is stainless steel pipe with nipple, 2 caps. This cap is on really tight, okay? And so it's not going to come off. This one you can do it, and this one has a hole in it. So you can put in your char inside of this thing, okay? And you weigh it to the 100th of a gram, and you then put it, and you with the cap on, you put it in there, and you put it into a furnace, into the fire, in order to drive it off, okay? This is what you're basically doing for the mobile matter part of the test. It has to be dry to begin with, okay? We've already talked about how the water is a factor in it. So you do that, and now the difficulty is you need this to go to a certain temperature, whether it's 550 or 650 or whatever the temperature is, in a commonly called a muffle furnace, which could be $500 to $1,000. And in America, I don't know what it would be overseas. And it's laboratory type equipment. Controls that temperature in there nicely. You cannot just take this thing and put a blowtorch on it and make it glow red hot and say, I just made this stuff hot. You don't know how hot it went. You don't know how long it was there. You're going to get different results with the same biochar, running it differently. So it's not a just anybody can do it any place they'd like to. But the BBM method, if you've got the muffle furnace and the accurate scale, you can do just about everything else that you need to do, okay? And the labs and stuff that are going into that. So that's this part, okay? Now, on the ash, the way that they measure ash is they take a sample, and he uses use a crucible, but how about a tuna fish can? You know, kind of shallow, about that big around, and you put your char into that, and you weigh that to the 100th of a gram, and you put that into your furnace to make it hot again. And this time it's not a cap on it. There's air around over the top, and you can actually, with a good nice rod, stir it or rake it a little bit to make sure the char gets exposed with oxygen that's going to burn off, and this stuff basically becomes ash. What you have done is when in the ashing process, you've burned off the mobile and you have burned off the stable or the fixed carbon from it. The only thing that you have left is ash. You're getting some numbers so that you are then able to come up with your evaluation. Okay. The name of the test is a proximate analysis. The name says we're not so sure it's so accurate, but it's approximate. This comes back from a couple centuries ago. It is not absolutely so exact on the type of thing. They even called it approximate analysis. The other analysis is called ultimate analysis, and that's where they're looking into the ash and they're saying how much of it is sulfur, how much of it is copper, how much of it is phosphorus and stuff like that. That's a more chemical analysis. Proximate analysis and ultimate analysis. And the way I learned to appreciate it is proximate is approximate, okay? It isn't, so they're trying to get these numbers in here. And so this is why when you're selling your carbon removal credits for your biochar, you could be at, you could be off by several percent into there, what the number is going to be. And then that's how you, and so they're going to pay you on proportion there. Everybody's accepting the rules of the game. They know it isn't exactly the same thing because the sample of the char that you went and got, technically out of this pile of char, you should have gone to 6 different places and taken a little bit each from each of those places after the whole thing has all been mixed up first, really mixed, and then take a little bit of each and have that stuff that goes into there and doing it. But remember that this pile of char over here and that pile that's over there, they're not necessarily the same, even though they're made with the same equipment, the same biomass, same crews, same people. There is no proof that that one is the same as that one. This one, you can test it as much as you want, but it's still only the result of this, and it's only based on random samples of where you picked your stuff out of it. So do not believe that this stuff is like absolute. So somebody says, oh, my char is 74.29% stable carbon, fixed carbon. How are you getting 2 more decimal points on the percentage? You're probably lucky if you're within a percent, okay? That would be very happy in what you're going to do. There's a difference between accuracy and precision. Precision is you measured it very, very precisely, but it just isn't accurate. We know what the scale said down to 3 digits, but we're not so sure that the scale is right. Are your scales being calibrated regularly? And I'll finish my last part on this thing here. I got a, there's an example of it. Thermocouple. Thermometer and thermocouple. How many of you have this equipment in your biochar production facility? 1, 2, okay, few, not many. If you don't know the temperatures, at least you're guessing otherwise, this gives you an approximation. I mean, it gives you a good idea as to what's happening into there. I recommend it. I mean, they're for sale, and that is about $100, and one of these new in a case is about $95. I've got the receipt, the stuff in there, but this is material which is hooked up, and you can put it measures only at the tip, and there's other different types of tips, and if you put this thing on, turn it on, and you wave it, that's room temperature. You put your fingers out there, you will see the temperature rise because the heat of your fingers is going to be measured, okay? This is just science materials that relate in with it, and then scales for how do you do your scale things. The time is lunch.